Okay, so here we are now again in the clarification portion of this video. I always have to do those because there's always stuff that I've been unclear on. And I understand that. So now we're going to address some of the things that I've been unclear about. One of the things I mentioned was that I punch out the primer pockets. And I do it with a punch that I took out of the die, and I indicate that it's the die that I show on the. So I'm going to go through and I'm going to pan down here. Clarify the dies that I'm using. Clarify the punches that I'm using, and also show you that. In my last video when I showed you a 100 thou punch hand holding the 50 BMG reamer, I didn't go 100 thou. I screwed up my reset, and I reset when I was already disengaged. I only punched in about 30 or 40 thou. I noticed it, but I was talking. I had no way to recover. So as I did is I decided to punch 100 thou deep on the reamer, leave it loaded up, and carry it in here and show you what a 100 thou punch looks like. Hand holding a 50 BMG reamer. It didn't touch down. I'm just holding it with the strength of my fingers. And when I say the strength, that's not because I have strong fingers. I'm doing that because this is how I eliminate completely any chance of chatter. To a machinist, the answer to chatter is always to stiffen the assembly. Unfortunately, that's a pipe dream. That's childish, it's silly, and no matter how big and good a setup you've got, there's no such thing as stiffening up the assembly completely. I'm going to have to play with lighting a little bit because this is kind of off the cuff here, guys. Bear with me. Playing with that. Let's see if I can get a focus on those little metal particles down there. I think I've got it. When it comes to chatter and reamers and reaming and all that sort of thing, most people have never taken the time to understand machining and how a reamer works and how a reamer cuts. Instead, they've learned in a shop somewhere and they've been given a bunch of hokey rules by the people in charge, and they're supposed to follow these rules, and that's enough, and they consider that to be God's own gift. When in simple fact, most of the reaming and machining practices that people have are based on the work of others, and the people implementing them don't really understand them. But instead, they argue profusely about stiffness versus feed rate versus lubrication versus... And I fight this because in our world, what we get is people claiming that somebody's reamer is a piece of shit and it only cuts on one surface and different flutes. And, you know, if I could ever get a reamer out of Joe Blow that would cut on more than one flute, I'd be happy, and this reamer's better, and this reamer maker is better, and this barrel maker is better, and 5Rs are so hard, and on and on and on. I just don't have these problems. Just don't. These problems are the result of poor machining practice. So, I'm going to show you why I handhold a reamer, and I'm going to assure you right now, I have a couple episodes, and that's where some of this stuff is showing you how I rig up the hand ream for headspace. Understand, I am hand reaming for headspace, but headspace is child's play. Headspace can be done by a knock-kneed technician that doesn't even know how to apply his math other than formulaically. It doesn't address things like flex and chatter, etc. It just addresses numbers. So even though I hand ream in here to fit headspace, what's more important than that is the diametric dimensions on the chamber, the size of the chamber. I've had chambers cut by a lot of different people, and most of them get the headspace between 2 or 3 chambers, 5 chambers within a thou or so. That's why Skip Auto made die shim, so you could shim the dies up and down a little bit. But headspace is only a small part of the problem. The bigger part of the problem is that diametrically very few chambers are the same size. And I will say that hand reaming the chamber doesn't materially affect that. Out on the lathe, I hand drive my reamer, normally using a flat-faced pusher, so that it makes the reamer center. In this case, I'm actually driving it off of a live center, which has some necessary play, making sure that my quill is extended far enough that it has some necessary play. So as much as possible, even though I'm pushing this, there's a little hole in the back of this reamer. Even though I'm running a live center into that hole, I'm not trying to straighten anything with it. In fact, I'm trying to get rid of all that. In the same sense that an old worn out partner reloading press will load straighter ammunition than a 72-pound Hollywood with a ram this big around, or some fancy, this is the same rant I've been on before. Understand your tooling, people, and life gets a lot easier. Life is hard when you're a dumbass, or life is hard when you're incapable of figuring out how or why things, or unwilling. The biggest problem is unwilling. I use incapable with reservation because you're all capable. Everybody's capable. But do you care? And if you do care, do you have access to the information? That's what this channel's about, is to show you how things actually work. Go watch, there's a bunch of them on the internet right now, engineers who are explaining things that are counterintuitive, and they're fascinating to watch. Because they show you why things work. Shoot, Destin from Smarter Every Day has built silencers, suppressors, out of clear Lexan or Lucite or something plastic, and fires them in slow motion and shows you how a suppressor works. That's cool. That's really cool. And it takes, well, I'm going to try to explain to you a little bit. I brought this reamer in, loaded up. This is all the stuff that came off of it. And I mentioned a few things that I want to clarify. Number one, I mentioned that I wore a glove. Now, I'll show you in a minute why gloves are a bad idea. But in the meantime, I'm going to show you that I did wear a glove on this, because there is I felt that it was, even though there's no chance of me losing a limb or truly hurting myself, which by the way is the right way to look at lathes and tractors and machinery. It's about losing parts. It's not about, owie, I need to put a band-aid on that, or I might need stitches. But there's a few things I need to show you about. This is a big reamer. Now granted, I got a little 2,500 pound lathe, and I got a little this, and all the machinist people are out there, you and your crap equipment, you and your crap, you can't even. But I will tell you this, me, can make identical chambers. I've never met anyone else on the planet that could. So, since I'm making mechanical chambers, I'm going to use this big reamer, making identical chambers. I can make chambers that are the same. I'm showing you how the flute's loaded up on this big reamer here. And to let you know that when it comes to flex and that sort of thing, as I'm rolling this thing around, I want you to look closely at a few of the things that you're going to see that are going on as stuff drops out of here. No matter how big the reamer is, and no matter how stiff the assembly is, I guess where I was going with my light lathe comment is, if I had a 10-ton lathe, and it was set on concrete and this big reamer, it would still, if you drove it properly, cut like this. It's cutting on all flutes, but is it cutting evenly? No. The reason for that is flex. The reason for that is that no matter what you do, when this thing starts to cut and you're driving it, it humps, it twists, it humps up like a monkey ucking a football. And people don't realize that. They picture this in its static form as though it is just going in. there's actually three kinds of reamers. There's straight fluted reamers, and there's helical reamers with right hand and left hand helical. All trying to eliminate this cutting differently on different flutes. Look at this flute right here, for instance. It's got heavy curls in there. It's also got shavings. It's also got an area that's not cutting at all. Immediately ahead of that is another one that's taking shavings. Immediately behind that is another one that's just got flake. And as I can roll over and over, this is a 100th thou peck. Done by hand, with my fingers, wearing a glove. I wore the glove because I feel I can get better feel. This is it's like learning how to run hand tools. You go with what works. I don't recommend wearing a glove, and I'm going to show you why that is. But this is just to show that this reamer humps up and cuts differentially on its surfaces. Now trust me, after taking 10 pecks with this, sometimes it's this flute, sometimes it's this flute, sometimes it's this flute in these different places. This is because this is flexed out and cutting, this is flexed out and cutting, this is cutting, this is flexed away and not cutting, this is flexed out and cutting. It's because the reamer has got, call it what you want, it's helicaled up a little bit, it's humped up. So, I just wanted to bring this in to show you that number one, that cut I showed you in there was not a 100th thou plunge. That's a 100th thou plunge on a 50 BMG held in the fingers. Now, the reason we don't wear a glove, I'm going to touch on this while we still got the camera up there. This is me wearing a glove. This is the glove. I was contouring a custom 338 Macallan barrel a number of years ago. And I understand, I knew not to wear a glove. I never wear a glove. I wore a glove for approximately 30 or 40 seconds of my life. And this was the result. I had a spot in this barrel that I'm contouring that had chatter, and I could not get rid of the chatter. I tried this and I tried that. So, I was sanding out the chatter, and as I was running the sandpaper up there, it got hot. And because I'm sometimes a wicked dumbass, I put a glove on to protect my fingers from the heat, and I took my piece of sandpaper and I moved back in and I went back and forth, and the thumb bit in and sucked itself around the barrel. Now luckily, I grew up on a farm, so I had a lot of calcium, so I've got strong bones. This is days later, and I need you to understand that this right here is very attractive. This is after the doctor did a lot of work. The circumstance of this was, that thing went in, the lathe was on just fast enough that I had time to think for about 40 seconds in my head as I'm being sucked in. I braced my body against the lathe, I braced my arm around the lathe so that when it sucked my thumb out by the roots, I was hoping to just get the thumb pulled out and just lose the tendons in this area and save my hand. I knew that if my hand got rolled in there, it was going to roll up my arm, and I could not get to the lathe switch because this is my left hand. No, it's actually not, it's my right hand. But these were the way I was thinking about it. I was freaking out a little bit, going, I don't think I can hit the switch. The point is, this split across, and it was all balled up in this area. And the way it happened is my hands were strong enough, my bones were strong enough, that it sucked in. It is actually this thumb right here. You can't even hardly see the scars anymore because I heal very crazy well because I don't eat vegetables. But anyway, I can't even get around to it. Trust me, this looked really bad at the time. Right now, it's all stitched up and cleaned up. Doctor cleaned it up, swelling is down. I decided to take a picture of it. Got back, got recovered. But when I got sucked in, the lathe was turning this way and it sucked in like that until that thumb started to roll up. And I was saying a little prayer that please let me get my thumb sucked out of here so that I don't lose the whole arm. Or die. You get sucked into a lathe, generally you die. Don't look up internet pictures. There's things that you can't unsee. Don't ever look up pictures of lathe accidents. Long story short, the glove did come apart and it stuck to the barrel. And I turned my hand over and I could see the little white tendons in there. I couldn't see the bone, but the meat was all pulled out to the end of the thumb. And I could see tendon material. And I looked around and I wiggled my thumb like this. And immediately I stopped. It hadn't barely started bleeding at this point. I curled my thumb in like this and I went like this and I put my left hand high in the air and I said, "Thank you, Lord, for another freebie." Because I could move my thumb, the tendons were not severed, even though they clicked and they chipped and they made weird feelings. The blood was starting to ooze, the meat was pulled up. I went like this, like closing a dead man's eyes. I closed my hand like this, I ripped off my shirt, I wrapped it around, I walked up to the house. And I got a ride to the hospital. And he opened it up, tucked everything, put 10 or 12 stitches around there, cleaned it up, swelling went down, boom. But I saved the thumb. That's luck. So understand that I have had a lathe accident and got away with it. This hand chambering thing is not about anything but getting the proper result. It is specifically about getting the proper result, both diametrically and then maybe even hand chambering later. So I have quite a setup here, speaking of that. These are just some of the things that you go buy. It turns out that a 1/2 inch extension will fit on a certain size. I don't know what it is. 5/8, half. No, this is a 3/8. I think this is 1/2 inch tubing. And this is a bigger setup because this is what I'm using for the 50 BMG. I have a box of parts here. Little 3/8 ratchets. Shorter chunks of this stuff, which are already burred out so that they slip fit together tightly, but they do slip fit together. So this is to show you the setup for the handshake. I use automotive tools and tubing. Then I need to clarify a few things. I showed you this and I said, this is what I use to pop out primers on the 50 BMG, and I stole it out of a die, and then I'm later working on this Lathe sizing die. And at one time I was trying to put a cartridge into it backwards, and this was in the way, the decapping pin. Well, this is not the decapping pin from the Lathe die. This is a decapping pin from another Lathe collet die. It comes apart. I bought a cheap set of Lathe sizing dies and seating dies and a cheap Lathe collet die. I don't particularly, the collet die is a neck sizing apparatus. It does give accurate results. It's fine. It's not something I use a lot of, but I got one for the 50 BMG. And this decapping assembly that goes in the back. But anyway, it came out of a Lathe collet die is where I got this priming tool, depriming tool that I've been using. So I just needed to make sure. Now, this die is one that I'm going to have to recut and modify. If it's cuttable, I don't know. When I cut the bottom off, it cut pretty good. This is not removable from the factory. It's threaded and it comes up out this hole with threads. And there was nothing I could do to get it to break loose, and I didn't want to call Lee and bug him. So I went in from the back side and I drilled, and then I took a carbide reamer and I rubbed the proper size and I reamed. And this actually comes up. You could see it in there if I could get the light right. You could see it moving. It almost comes out the top. But I cut the threads and everything out, and I left something that goes back in, right where they set it. And I can now glue a piece of all thread into this, poke it up, and the all thread will stick out the top, and then I can screw a nut on here, and I can turn the die back to a decapping die. But I had to have a lathe to be able to do this. So this is actually the decapping pin from the Lathe setup. And I just wanted to show you that you got to buy another one. So I'm going through, as I said, it's about saving money, it's about cheap. Now another thing is, a while back I did a chainsaw video. And I got to say, just to add on to the end of this, the spinifexes came in. Woo-hoo-hoo! I mentioned as how there used to be an assembly that on my chainsaw video I'm using a rechargeable angle grinder that only turns one way, so you got to do one side of the blade, one side of the teeth are cut with the saw with the cutter right side up. On the other one you got to go upside down because we're cutting a given direction. Well, this right here, Turtech Technology Inc., it's called a Spinrite. They just started production again. I'd mentioned in one of my other videos about how this used to be around. A couple of engineer kids came up with it. They're up in Canada. This is all written in French. Spinrite, it doesn't have it on here. Reversible angle grinder. The box has a bunch of French and it comes out, costs retarded money. 160 something Canadian. Luckily right now we're less stupid than the Canucks, so our dollar's worth more than usual. It's really gained on the euro and all the British pounds and stuff, but it's also gained. So right now that 160 something was only 120, so still $120 machine. Now it does have some problems in that it's unsafe. Like most of the things that I show you, I have to make it safe. This particular gadget, you push this forward, then you squeeze the handle and it goes berm this way. You pull the handle and you squeeze the handle and it goes berm this way. Well, that's a good way to hurt yourself. The first thing you do to not hurt yourself is you take the crap off the front so that you can use the whole blade. Then you take a 1/2 inch by 1/2 inch piece of something. Let's see if this will work. There you go. This is not what I use. I have a couple little 1/2 inch blocks and some tape. You pull this back, you drop a block in the hole, and then you wrap tape over it and you tape this handle down at the same time. So now the machine is live. You hook it to a foot feed, like I show you on my videos where I'm shaping aluminum. This is the same thing. You set this thing up like one of those aluminum shaping tools. Now you've got to get a DC inverter, DC to AC inverter, because this has got a cord on it. Big long cord, by the way. You've got to be able to plug it into your off-road machine. So in my case, I've got my Gator set up with an inverter right on it, so I can just plug in and go. And now with a little modification, these are back and they're now available. And there is a reversible angle grinder for sharpening chainsaws. It's the wickedest thing in the world. So, just got to whip that in on the end. Thank you very much.